Welcome, welcome. So glad to see you all here. I am originally from Denver, so I had a short plane ride here, but I was really excited to come to this conference. It's my first time speaking here, so excited about that. Anyway, this talk is actually a combination of material that I feel is super important to get out there in order to increase awareness about security as a developer. And that includes the development of AI and ML projects, other frameworks and tools as well. And awareness about where you are getting and storing the software binaries that you use and build for your projects is in fact just one part to be concerned with. How many developers out there? Okay. How many are either relatively new to software development or you do it, but it isn't your primary job? Okay, cool. We've got a bunch of developers in here. All right, a lot is going to come at you fast. I know it's the end of the day, but these slides will be available for you, and there's lots of resources in them you'll be able to refer to later, or you can reach out to me on Twitter or LinkedIn. Okay, most important thing on this slide is my contact info here. Also, I am a developer first and foremost. I work for JFrog currently as a developer advocate, but for over 20 years prior to that, I was a developer all the way from your lowly intern to a principal engineer. And so most of my talks are definitely from a developer perspective. Even though I'm working for a DevOps company, I hang on to that developer side pretty strongly. The other item I'll mention here, I am an author of the book DevOps Tools for Java Developers. Java is my primary background. And I co-authored that with Baruch Sadogursky as one of the co-authors, and he's going to be here tomorrow. So just a quick plug for him. He's doing a session in, I think, around 12, at a little after 12. All right, fairly recently, I had the privilege of working on a little project with Damian Curry from Nginx at F5. We were developing a series on YouTube around the application journey. And Damian comes from an operations perspective. I, of course, come from the developer side. And we decided to have an informal conversation about what it actually takes to develop and deliver a cloud-native application. We had a number of episodes. We tried to start from the very beginning, from just planning a project, all the way to not only just deploying that project, but observing that project and making sure that you get feedback all the way into the beginning of the development loop again. And some of the topics in episode 3 are what I'm going to be focusing on today. And if you can imagine, some crazy things came up. And one of the most important things that I realized was that developers are not security experts. We're optimistic folks. We like to build things. We like to build tools that solve some problem in the world, or even just to make further development a little bit easier for other developers. I believe I'm right in saying that securing our software isn't often at the forefront of our minds, especially early in our careers. This was my very first intro to security. How many of you recognize this page? All right, this is just a typical Apache default home page, administration and stuff. And my first job was to go through and make sure this did not appear on any of our projects that we had out there in production. And this was security through obfuscation. And I never had even thought of it before, but I was told at the time, and we can argue about this later, whether this is a good way to do things or not, but I was told at the time that even just revealing the version number of the web server that you are running could be a potential attack vector. If there are known vulnerabilities out there, you're done for. We can all agree that downtime for any reason is a problem. It can affect your organization's credibility. It can affect your customer personally. It can certainly affect your pocketbook in the way of lost time in production, lost customers, and in worst cases, lawsuits and fines. And with that, we'll whip through a couple of old but famous hacks and talk about some of the real consequences. So this is Log4Shell, and in a nutshell, this is an exploit where one can trigger remote code execution by providing a string in a certain format that ends up being picked up by the Log4j library. That turned out to open up the ability to initiate an LDAP lookup, fetch some compiled code, and execute it. And just about every Java developer out there cringe their way mitigating this particular vulnerability. And according to Stephen McGill, Vice President of Production Innovation at Sonatype, approximately 70,000 open source projects use Log4j as a direct dependency, and nearly 174,000 projects use it as a transitive dependency. So this is not a simple problem to solve. It was widespread and a big deal. The Equifax data breach happened through March through July of 2017. So some time ago, but enough time for us to now realize some of the costs associated with this. This was due to the Apache Struts vulnerability, and unfortunately for Equifax, it was a known vulnerability. $1.4 billion in cleanup costs is estimated, 1.38 billion in consumer claims estimated, 147 million customers were affected. The Equifax breach was an example of a data breach, just one though, and there's been a lot more since then. So this is another scary stat about data breaches. This number is huge, 4.45 million in USD. The average cost of a data breach in 2023, and that's a 15% increase over the last 3 years. We hear about these a lot, and this is a website that I found, and it keeps a really good update cadence on the new ones that are coming out. There's at least a few every month. Some of these may be due to social engineering, maybe phishing, or employees are getting tricked into giving up a password or something. But 3 breaches that were on this site that happened relatively recently stood out to me, and all of them are from this year. So we have June 1st, July 20th, and August 11th. There were 3 data hacks that had to do with the MoveIt transfer tool. There was a featured article on TechCrunch about this. I have a QR code for that. Carly Page described the MoveIt hack as the biggest hack of the year by the numbers, and if you were to read that article, it's pretty horrendous. So why does this keep repeatedly happening? We aren't helpless. It can feel that way, but we're going to dig in a little bit and figure out what vulnerabilities actually look like, how we can better protect ourselves. And I mentally divide attacks into these 2 buckets, those that involve code, artifact, or package security, and then everything else, which involves maybe configuration, system, or network security. I'll touch briefly on the everything else bucket at the end, but I'll be focusing more on some of the ways that I relate to, given my background as a developer. That's going to be mostly around artifact and binary management and coding defensively. So this brings me to our first step in troubleshooting this problem. Let's go to the very basics of a developer workflow. This is intentionally simple and naive, but this is actually what we do day in and day out. Would you agree? We write code, we build it, and then we run it, and then we repeat. So where is it exactly that we get tripped up? How many of you agree with this statement? As a developer, it is my responsibility to write code that is secure. Good. This is reasonable. I found this essay out on the OWASP website. Just a quick plug for OWASP. They're the Open Web Application Security Project. They are a nonprofit foundation that works to improve the security of software. They were launched in 2001, incorporated as a nonprofit charity in 2004, so they've been around quite a while and are, there's a ton of experience behind its members. And one of the things they do is provide security resources for developers and other practitioners. So I went to check them out, found this essay. It's pretty funny. It lists ways to write insecure code, opposite of what you would expect. So if you enjoy sarcasm and some irony, this is definitely for you. There's some pretty clever points in here. And a few of them I wanted to pull out just because they made me chuckle. I like the always use default deny. So deny that your code can ever be broken, deny vulnerabilities, and unless there's a proven exploit, and deny to your customers that there was ever anything wrong, and deny any responsibility for flaws. Secure languages. Who all here writes in a secure languages only? Yeah, you all are smart. None of us write in a secure language. There's no such thing. Mixed languages. I've been on projects where we've had a number of different languages involved, and for good reason. There were legitimate cases for this. But this is funny just because, yes, the more languages you add, the more difficult it is to learn them all. So the idea is to obfuscate vulnerabilities through using all kinds of different languages together in one project. This one, finally, I put on a slide on its own. I'll let you go read the rest by yourself, but this one really made me laugh. Rely on security checks done elsewhere. I've heard this argument a lot, especially for a development team. It's redundant to do security checks twice, so if someone else says they've done a check, there's no point in doing it again. All right, how many of you were formally educated in software engineering or computer science? And you took a security-focused class before getting employed in the field? Okay, there's 3 or 4. By security-focused, I mean a class that maybe had the word security in the title. How many of you, the rest of you, if you were not formally educated, have you taken a security class? Good, good. This is getting better. I will admit here and now, I did not take a security class during my education. This was way too long ago, maybe before it mattered as much. My personal experience was getting trained on the job. It was not part of my formal education. And fortunately for me, my employer was very much about this, making sure that we learned how to code defensively and safely. So I learned all the things, and I really thought I knew all there was to know about secure software. I was done after I was done. Clearly, that's not the case. There are a lot of other things that a developer needs to be concerned with. We really need to consider developer maturity when we're making decisions about our security posture. Junior developers, obviously, or anyone whose primary job hasn't been in software, are going to need more guidance and oversight than more experienced developers. Even if a developer has gotten training in the best practices to code, and they're a master at writing code without securities, there are other significant vulnerabilities a developer can still become prey to, and I'll get to these in a moment, but some of these you may not have control over. So it's important to know, where you can actually make a difference and where we need some help from other teams in our company or organization. So let's review our very simple developer workflow, and let's make it look a little bit more like reality. And it turns out developers love to write tools to make life easier. That's really all that software is. And developers also detest reinventing the wheel. It turns out that organizations also don't enjoy paying for reinventing the wheel. So this whole idea of free and open source software that can be used and built upon by developers pleases many levels of the business hierarchy. So we continue, we write code. Maybe we declare more dependencies as we learn more about our project and our requirements. We build the code, we run the code. And then lastly, if the code is not proprietary, a developer may contribute their creation as free or open source for someone else to build on top of. So let's accept this as a reality. We need to talk more about dependencies. And I went to a session earlier today by Dean Wampler just before lunch. Did any of you attend that session? No? Okay. He touched on this topic a little bit. That there's a concern about imprudently bringing in packages and libraries and building off of them without considering carefully where these packages and libraries come from, or vetting their compatibility, their maintainability, or even their security. And this is really easy to do. Package managers and build tools often make that easy on purpose, and many that are creating don't stop to consider, or they just might not be aware that this is a problem. So when it comes to analyzing the projects that a developer typically works on, the reality is there's a ton of code that he or she did not write. It's code that someone else has written, and there's a lot of trust involved, trust that can sometimes be misplaced. An answer, maybe we shouldn't bring in any dependencies. This is not the reality of today, and in most cases it would be cost prohibitive to require a development team to write everything from scratch. Just for grins, I went to a demo project that I've been working on. I selected one of the components to analyze. This one component is one of 7 microservices involved in this project. This is a Spring project, Spring Boot project, and I did a little Maven tree on it to figure out how many dependencies I had. There were 114 direct and indirect dependencies, as many as 7 layers deep. This is code I will never look at. I've never seen before. It's code that I build on top of. So this is concerning in a way. This is from the Open Source Security and Risk Analysis Report, and it includes the Cybersecurity Research Center findings for the year of 2022. They scanned 1,703 commercial code bases across 17 different industries. And I took these 3 graphs from the section on the use of open source. I thought these 3 industries, were pretty interesting to look at. And note that the lighter color represents the percentage of the code in code bases that was open source. And also note the red line indicating the percentage of code bases containing high-risk vulnerabilities. And notice that little uptake in 2020. This would be a fun discussion to have during our happy hour tonight. I don't actually have an answer for this, but I do have some theories, and I suspect you all might have some too. There are some risks that we inherently take when we bring in dependencies without vetting them. We could bring in a dependency that's vulnerable already. We could bring in an unintended version of a dependency, something we weren't planning on, but we ended up with. This could be both internal or an external dependency, so it could even be one that was built in-house. We could bring in the wrong dependency altogether. We'll talk about that in a little bit. Or we could fail to update dependencies as new vulnerabilities are discovered. And then, of course, what about those dependencies? If we can't scorch the earth and just get rid of all the dependencies we're using, then what can we do realistically? Well, the next step is to understand what kinds of vulnerabilities we're dealing with and put tools and processes in place to protect ourselves. So this first one, an unintentional vulnerability, that could be a weakness in the code. A developer perhaps wrote something that is now exploitable, and it's out there in the wild. The second one, and this could be an intentional backdoor built by a developer, either for legitimate purposes or malicious purposes, but it's something that was done on purpose. And these two, once that's discovered, will be registered with a CVE, a Common Vulnerability Exposure ID, to be shared publicly so that everyone can respond and mitigate appropriately. The third one, malicious components, these don't get a CVE. These are ones we need to watch for ourselves. And I'll talk about those more in a minute. It's very difficult to manage dependencies, both internal and external, or to even respond to publicized CVEs if you don't know exactly what you're using and if you don't have a centralized location for them. And this is where a repository manager or a binary artifact manager comes into play. And despite the type of license that these packages have, whether they're free or open source or they're corporate licenses, these packages are made available to developers often through public repos. You all should be familiar with these. I'm talking about NPM, Maven Central, PyPI, Docker Hub, the list goes on. And I'm not saying that these public repos are bad. They absolutely have their place. This is where you collect them to begin with, right? You go out, you look and see what's available. These are for developers to contribute to and also for consumption. But if you choose to use a package that originates from a public repo, bring that package into your artifact management system at the get-go. This way it's under your control. Having all of your packages you require for your builds organized within that repo will make some other tools work better for you. You'll be able to regularly scan them for known vulnerabilities, for example. All right, let's get into malicious packages. You probably are familiar with these. We're talking about the ones that involve dependency confusion, dependency hijacking, typo squatting, and brand jacking. These are pretty serious, and a lot of the public repos need some help with finding these. We have a security research team at JFrog. A lot of organizations have this now. that continuously monitors popular repositories with our automated tooling, and we report malicious packages discovered to the repository maintainers and the wider community. This is something we all should be involved in and helping with. Now, I want to pick on something other than Python right now. This is a dependency confusion attack, and it was described by Alex Verson in a blog on medium.com, and it was a couple of years ago that he wrote about this. Most projects have a collection of dependencies that need to be brought together. They include open source or publicly available packages, as well as internal packages. And what I'm showing here is a typical package.json file for an NPM project. And what's highlighted are internal package names, meaning the organization has built these packages. They could be proprietary. They're meant to be internal packages. Note that the version requirements for these packages are either the version specified or the one with or something greater that is available, and that's indicated by the caret in front of the version number. And also, these package names are not secret. When you make a request, those NPM requests inform about these internal package names. So they're easy to find. So what that means is, for example, if a request is made for a corporate lib that it's expected to come from an internal repository, but it just so happens that there's a package with the same name with the greater version out there in a public repo, and it's not yours and potentially malicious, your package manager will pull that one instead. And who knows what's in that package, or if you'll recognize it right away. So by the time you deploy it, you've got trouble. So one way to protect yourself if you have a repository manager or an artifact manager is to control these requests for internal packages. Instead of seeking out a public repo right away, proxy through your artifact management system in order to, you can specify that internal package requests can only be resolved with internal repositories. And that's one way to protect yourself. This is if you are aware of the problem to begin with. I don't know if you know, do any of you use PyTorch? No. Okay, PyTorch is an open source machine learning framework, and this is something that happened with them. For about 5 days at the end of last year, there was exactly this scenario where if you took the nightly build of PyTorch, you would get a compromised dependency coming from a public repo when it was supposed to come from their private repo. So that vulnerability has been around forever. It was described in really good detail by Alex. And he got some pretty big bug bounties off of this one. OK, here's another fun one. This has more to do with managing open source packages and libraries themselves, not really about a malicious package or a vulnerable package. But this illustrates a trap we fall into when we rely solely on public repos. The left pad incident. So Kik is a chat app, and a developer had a package named Kik, and there was a disagreement between the developer and the Kik organization, so they brought it to NPM. NPM sided with the Kik organization that they should own the package named Kik. The developer, maybe, I presume he was unhappy with this decision, decided to unpublish not only his Kik package, but he also uninstalled 272 other packages, and one of them was named leftpad. Any of you use React? All right, so React was affected by this. This is a tiny little library. This is all it was. And this is all that got uninstalled from NPM and caused a lot of havoc. So this could happen. What about a package that is compromised or replaced entirely by a malicious actor? I mean, this is one that just disappeared because the creator decided it needed to. This could happen if someone were to gain access to the maintainer's account somehow. All right, this is a combination of problems here, a little bit contrived, of course. I'm not going to go through all of them, but just line 1. Picking an untrusted parent image. A lot of these Docker files that I see, especially examples online, They're pulling directly from Docker Hub. Consider pulling in your parent image into your own artifact management system and pulling it from there instead. Even if you indicate a tag of an image can get replaced out from under you, and this is a huge problem. The other issue here, line 7, dealing with something that you're pulling from a remote resource. I see, curling out for these things quite often. If this is an internal location, that's fine. But if it's not, it could get moved out from under you, updated out from under you. It could be updated with something that's incompatible, all kinds of problems. Also, I feel bad about or talking about containers running as root sometimes. This is something you should not do. I'm sure everyone's heard of it already. But even so, SysDig put out a report in 2022 saying 76% of containers were still running as root. All right, so is there any hope? There are things that we can do. There's things that have been done. We've had some regulation come about. We've had creations of the CVE, the National Vulnerability Database, and CNAs. JFrog is a CNA. These are the organizations that can actually create CVEs. We've had a lot of development of new tools. We need to talk about this more. We need more education. So more on education. OWASP has a fantastic set of cheat sheets. If security is new to you, if this is something you want to research more, definitely a place to go. There's also a trio of free courses by the OpenSSF. I'm in the middle of these right now, and they're pretty good. You can pay for them if you want to get a certificate, but you can audit these courses for free. Don't rely solely on public repos. We talked about that. Manage your dependencies, but not just your dependencies. Think about everything that you bring in for your project, all the tools and frameworks that you use. Do any of you recognize this landscape? Okay, we got one. This is the CNCF landscape, the Cloud Native Foundation landscape, everything that's involved there. I like jigsaw puzzles. I thought this was great. It just gives you an idea of how much there is in the out there in the ecosystem that you can use. And just being a part of a foundation is good. There's another foundation I'm involved with called the CD Foundation. It's a sister to that. They're both under the Linux Foundation. And the reason I say that it's good for a project to be in a foundation, there's different levels that they can have. So you'll notice projects start as a sandbox level, possibly an entry level. When they get to graduated, they have to go through some pretty intense security checks. So this is, some help to indicate that these projects are well vetted, that they're definitely maintained, and more trustworthy. Okay, manage permissions. We talked about what happens if you don't secure your access to things, especially the accounts you use to deploy to remote repos or to public repos. Keeping up with maintenance. I would love to get in more discussions with you all later about this one. Whether updating more frequently, as in updating these packages more frequently, causes more problems than it fixes. But it is best to know that a vulnerability will rear its head at some point, so it's easier to upgrade if you're on a later version than if you're on some super old version and then have to deal with that. So another topic for our happy hour, perhaps. Regularly scan your libraries and packages. I'm going to go a little bit on tools for this. We're getting better, but there's a lot more work that needs to be done here. One thing I'll complain about right away is dealing with long lists of CVEs on a developer side. We need to know when these things are applicable, when they actually matter, and when they should be prioritized to be fixed. Because it turns out that 78% of reported common CVEs, even just on Docker Hub images, are not really exploitable. And there's some reasons for this. It could be the library that's being pulled in is not being used in an exploitable manner. It could be a service configuration that's specific. It could be just the environment. For example, there's a Hadoop vulnerability that is only relevant if you're running on Microsoft Windows environment. All right, optimizing our CI/CD processes. Let me go back to that one. Are you rebuilding when you release? This is something I've seen on some pipelines that you should not be doing. You should be taking a release, it should be built once and then promoted through your quality gates before it gets to production. And finally, are you pulling and building your release artifacts from a known and secure location like a privately managed repository? I want to leave with who should all be invested in this process. Pretty much everyone, because it's not just developers that need to be involved in this. We need to empower developers. Don't just give them a list of CVEs. They are not security experts. And you need to have this culture in your organization to improve your security posture. All right, any questions? If you have any that you'd like to talk about later with me, or if I've mentioned anything that you want more details on, meet me up at the table 1 on the 4th floor, and I'll be there, ready to chat with you.